So hello everyone, my name is Pawel Maczka. So I'm really thrilled to spend with you next 30 minutes. With me, we have Marcin Kubacki from the Storware team, and we have Brian Sietsma from the Catalogic Software. So in the next half an hour, we'll go with the subject vProtect backup and restore of the Kubernetes containers. So fasten your seatbelts. We'll start with the presentation. So the Brian will do the first part. Then Marcin will show the live demo how it actually works in our live demo in our vProtect. If you will have any question, please keep the question on chat or wait till the end of the presentation. Then we'll have an official QA session. So then you can go unmute and ask whatever you want. But during the session, please, any hints or any suggestion put on the chat. So we don't want to disturb our host to make a webinar. So Brian, I'm giving you the voice right now. I'm going on mute. So again, thank you, and let's start.
Thanks, Pawel. Yeah, thanks everybody for joining. My name is Brian Sietsma. I am a solutions architect at Catalogic Software. Catalogic Software is the exclusive reseller of vProtect in North America. What we're going to be talking about today is, as Pawel mentioned, the growth of container technology and really more specifically, how to protect your data living in containers, especially in Kubernetes environments. We'll first go through a few slides. I'll run through a few of these slides fairly quickly. And then Marcin is actually going to help with a product demonstration after this slide deck. First of all, what are containers? A container is a standard unit of software that packages up code, all its dependencies, so the application can run quickly and reliably from one computing environment to another. There's several different container development out there. Docker is one of them. OpenShift is another. But what we're focusing on today is Kubernetes in particular. So you might be asking, how are containers different than VMs, and what are the benefits to using containers instead of those VMs? There are really three major benefits to using container technology instead of your typical virtual machine. First, unlike VMs that stand alone, really don't interact with each other, containers share resources with other containers on the host system. This includes the operating system kernel and libraries. By sitting on top of the physical server or a VM, and obviously its host OS, containers are much easier to manage than virtual machines, who each have their own OS. They need to be taken care of. You need to individually care for bug fixes, upgrades, patch fixes. With containers, on the other hand, you only have to manage that single OS from the host server instead of each and every container. So that's the first benefit. The second is more focused on efficiency. Containers are much more lightweight. They require far less time to boot up than virtual machines. This makes it possible for an end user to pack a greater number of applications into one single server. Maybe hundreds or thousands of containers can run on a single server, where with virtual machines, it's simply impossible to host that many VMs on the same hardware. And then finally, the third benefit of using containers is their portability. Containers have the ability to move between cloud environments or even back into an on-prem data center. Now, if this is new, if containers are a relatively new focus for you, this might sound like it's the new shiny toy for developers that like to maybe mess around with this in their own spare time, maybe making some cool but rather impractical applications. Maybe you're assuming containers really aren't used in production environments. Maybe not enough people are really using them to really trust them in terms of holding critical data. But these assumptions would be more and more incorrect by the day. In fact, the projected market for the applications container technologies by the end of 2019 will be worth more than $2.1 billion. And this number is actually expected to more than double by 2022, up to a number around $4.3 billion. there's a specific survey done by Portworx and Aqua Security where they found out that a whopping 87% of respondents said that they're now using containers somewhere in their environment. This is up from 55% in 2017. So the growth is very noticeable. Some of the most obvious signs of this growth, signs that containers have really entered the mainstream, are the following. 9 out of 10 companies that use container technology are doing so in production. So of those 87% of companies using technology, using containers, 90% of those are actually using containers in production. So trusting these containers to hold critical information for those production jobs. And then finally, in 2018, only 17% of IT operations teams were really driving container adoption. But in 2019, that number is up to 35%. So this is no longer becoming just a development, something to poke around with and try to make some cool use out of containers. But IT operations teams are really driving this market upwards. So long story short, containers are not just a fad being used by developers in test environments. IT teams as a whole are adopting container usage and ownership. They're dedicating large budgets to these container-driven projects and are using this container technology in production environments. Now, as more and more IT teams are using container technology in production, especially Kubernetes, it becomes increasingly important to make sure that the production data is being protected with some sort of backup solution. And that's where vProtect comes in. vProtect is a data protection solution really designed to perform agentless protection for what we call the other hypervisors. Originally, this was pointed towards the Citrix Zen servers, virtual or Red Hat virtual enterprise virtualization, KVM, Nutanix, Acropolis, things like that. We've actually added support for Hyper-V and VMware as well. But what we're going to be focusing on today specifically is Kubernetes. Before really diving into the specific details of vProtect support for Kubernetes, I want to make sure that I described how vProtect works from a high level. As you can see from the image on the left of this slide, vProtect leverages what we call vProtect nodes to act as the data movers for both backup and restore jobs. During those backups, a VM or container information is passed through that vProtect node and then pushed off to a specific backup destination of your choosing. What's really cool about vProtect specifically is their ability to integrate directly to your existing enterprise level backup solution. So this prevents you from having the need to really tear everything down, start from fresh. You can leverage, maybe you have a Spectrum Protect environment or a Veritas Net Backup, Dell EMC Networker, or even Catalogic's vStore from our DPX product. If you have any of these backup solutions, you can leverage vProtect to push backups from your OpenVM environment or maybe your containers environment to those same backup destinations. And then that way, from one single pane of glass, you can manage your backups from maybe your physical servers, your Exchange boxes, things like that you're using Spectrum Protect or these other enterprise solutions for, but also for your backups for your VMs and your containers. We also support some things as simple as a local file system, an NFS share as a backup destination, or cloud storage like S3, Azure, or Google Cloud. Even things like a data domain boost file system as well as that backup destination for those backups. Then obviously from a restore, the vProtect node will identify the data from the backup destination and pass that back to the hypervisor or the Kubernetes cluster and create that restored VM or that deployment using that data. Now for Kubernetes in particular, vProtect, what it does is it provides a crash consistent backup of deployments running in Kubernetes environments. It can actually back up both the metadata and the persistent volumes attached to pods running in Kubernetes. With a really slick user interface, it's very modern, it's very easy to use, very intuitive. You're quickly able to set up protection and store Kubernetes backups in any of those backup destinations that we mentioned earlier.
Hey, Brian.
Yes, go ahead.
Sorry to interrupt. I cannot really see your screen. By the way, are you sharing some slides or something?
I am sharing slides. Is anybody else having trouble seeing my slides?
I can see these slides, so.
I can see the slides.
Yes, same for me. I can see the slides.
Oh, okay. Yeah, I'm not sure. I'm sorry. What the issue is?
For everyone to know, if anyone has problems with the current, let's say, you sharing screen, this session is recorded, so you will be able also to have it available later online as well. So.
Okay, no worries. Thanks.
All right, thanks, guys. Yeah, so what actually happens during a vProtect backup for Kubernetes? vProtect automatically pauses those running deployments to make sure that those backups are crash consistent. And then the vProtect node actually creates a small temporary pod that attaches the persistent volumes from those target pods, reads that data from there to that data mover, that vProtect node, and then later passes that metadata information back to the backup destination. If you'd like, you also have the ability with vProtect to exclude specific persistent volumes from being backed up. And then also from a restore perspective, vProtect recreates that application using that metadata that is being returned from the backup destination. And by default, the application will be restored with the same name as the original, along with a string of numbers as the suffix to identify that newly restored deployment. But you also have the ability to provide a new name for that restored deployment as well. So whatever you'd want that new application to be stored as, you can provide a new name for that during the restore process. Now, before passing this along to Marcin for the product demonstration, I just wanted to point out a few additional features of vProtect that I think are important specifically for the Kubernetes workload. One great thing about functioning using those vProtect nodes as data movers, it allows us to scale out. Allows us to deploy additional vProtect nodes to help share the load across a large environment. Deploying those vProtect nodes are very simple, simple RPM deployment, and you can kind of point them to specific workloads based on your architecture of your Kubernetes cluster. The second piece here, everything driven through the UI is RESTful API driven. So we actually have customers that are using management or job management tools to actually kick off these jobs using those API calls. So if you have something like that in-house where from one single pane of glass, you want to kick off all of those jobs, you can simply call those APIs to make those calls and run those backup jobs from the GUI. One thing in particular specific to Kubernetes, I mentioned we have the ability to exclude specific persistent volumes from backup. But another useful feature is the ability to automatically include or exclude particular deployments from backup policies using name-based auto grouping. So in vProtect, you have the option to manually kick off on-demand backup jobs, but we also have what's called policies and schedules, and that gives us the ability to set up daily, weekly, monthly, hourly, whatever you'd want to do in terms of a backup schedule. But under policies, we actually have the ability to auto group specific deployments using a naming convention that you provide, whether it's a prefix or a suffix to those deployments. You can have vProtect automatically add or remove any new deployments to that policy as you go forward. That kind of keeps a management of that specific policy, assign that to a schedule, and then that will run based on that schedule, hourly, daily, weekly backups of those particular deployments. For non-English speaking accounts, vProtect UI is also available in Chinese, German, and Spanish as well. So if that's something that you will make your life easier, we can simply change that setting on the vProtect, update the UI to that particular language. And then finally, over on the left-hand side, you'll see an image of that actual scheduler, just to give you an idea of what the dashboard or what the UI looks like. Very easy to use, very intuitive throughout the whole process. very easy to use for new vProtect users. And with that, I will actually pass this over to Marcin. I'm going to go ahead and stop sharing, and he'll walk through the actual product demonstration.
Okay, thank you, Brian. So let me just maybe start with sharing my screen. I'll log out. So we have some demo environment here. So my name is Marcin Kubacki. I'm Chief Software Architect at Storware. So basically, I think I can answer almost any question that relates to vProtect because it's I'm from the beginning with this product. To summarize, basically vProtect supports many platforms. One of them is Kubernetes. So I believe that we are few aspects that we probably need to cover here as well. It's not only about the protecting persistent volumes inside the Kubernetes. We have also some features related to the generic backup approach as well. So here in this demo, I'm going to show you briefly how it looks like from the management point of view, what are nodes in here, and how we basically work with the Kubernetes artifacts from the vProtect perspective. So now let me just log in. So this is the main console. The same server basically also serves API calls, so you are able to access it over API or command line interface if you like. This is current release, so it's available for download. And here in our small demo, you can see in my dashboard that I have several nodes available. Nodes, but just keep in mind these are vProtect nodes, so they are data movers. I have several backup destinations. One of them can be like this one is local file system with the duplication enabled. And there are obviously some history and statistics available, usual for dashboard. So in our environment, I said that I have, this one actually is working that we need for our demo, 3 data movers. And we basically are able to assign configurations to such data movers. So if you have multiple nodes, you would like to manage them with a single configuration. So all of them have the same staging configuration, for instance, and access to specific backup destinations, then you're able to group them together. Now, the UI interface, the user interface basically is hypervisor agnostic. So I'm saying hypervisor, I'm saying virtual environment, but keep in mind that these terms are basically sort of transparent. So in Kubernetes world, our hypervisor manager is basically Kubernetes management node. Here I have credentials, so I can add my hypervisor manager, in this case, Kubernetes, and I need to obviously provide some credentials so that later vProtect is able to grab kubeconfig and is able to do all of the necessary tasks. In our case, I have one already here. I'll need to copy paste some token. Okay, so here we have Kubernetes environment with a small subset of the resources that we are actually using here in our demo lab. Keep in mind that we have seen Kubernetes deployments both on the physical boxes and on the virtual machine boxes. So if you think about protection for the virtual environments, in this case, you have to think about several layers. First is persistent volume attached to some container, okay? Container, well, basically several containers are actually a single pod. If you have multiple pods, basically they are a set of replica sets or a part of a deployment. So when we are talking about virtual environment in Kubernetes world, we are talking about deployment. We assume that basically deployment, if you have multiple pods running, they share common persistent volumes. They have some claims. They have persistent volumes that we need to protect. So here I have Nginx deployment. Basically, that is one of the deployments that we need to think of data protection in this case. So whenever I'm scanning for the deployments, basically vProtect connects, grabs all of the information about the running deployments and persistent volumes, etc. And this creates a task here. Everything is a task in vProtect, so you can synchronize inventories, you can export, store, restore, backups, etc. And now I should be able to see, obviously, well, hypervisors, which basically are Kubernetes nodes. This is, let's say, rather for informational purposes. The more important tab is here, virtual environment. So you can see that my Nginx is a deployment, yeah? You can see that Nginx deployment is the one that basically we want to back up. Inside such deployment, I have some general statistics, some backup history, if something failed, I also are able to grab log, etc. Now, as far as disks are concerned, these are persistent volumes in this case. You can exclude them if you don't need, but in general, this is what we intend to protect. Let's maybe initiate some backup. I want to create a backup and store it in our local deduplicated backup destination. So I'm initiating task now. This basically creates a task here in the console. It's export. It's always two-step process. So you have to export data from some source. In this case, it's Kubernetes, and later store it in some backup destination. So depending on your setup, this store phase can sometimes be optimized, especially if you're using local file system, because one of the commonly asked questions is if we have to double write data so that we dump data and later copy it somewhere. For enterprise-grade backup providers, that's perfectly true. However, if you are able to expose a single file system, you can use staging space together with your backup destination. Then the basically store phase is instant. So it doesn't take time because vProtect detects that it can move data without having to copy it again. So I have exported and stored data in my backup provider. So what has happened? We have actually had a small container running, which basically attached persistent volume that we have seen here. It grabbed data, and later it fetched from the Kubernetes and stored in our local file system. This obviously you want to schedule at some point. You don't want to manually do that all the time. So basically you create a policies, you have virtual environment backup, and whenever you would like to backup specific environment, well, let's say that I want to create a separate policy, it's like Kubernetes. You are able to either automatically assign VMs, or you want maybe to specify which of these VMs are here. So you can create some rules based on which you would like to add or remove VMs from automatically. In our case, maybe this Nginx would be nice to be added here. I have one selected, and the rule here is how we cope with each backup. So I need to specify when and where the backups should be stored. So let's say that I would like to select it, to store it in video and push it to the, well, according to weekly full schedule, for instance, right? So this is how the policies general are being created. You can create multiple schedules here. And according to your schedules, you are able to say that twice per day, maybe I would like to backup, maybe on some interval basis, because you can, as you can see here, you're able to specify that sometimes you would like to periodically backup some containers during your work hours, let's say. Then you assign to a specific policy, and you are able to see how what's the size of this, estimated size of this specific policy. You can distribute this workload so that you don't have all of your environments being backed up at once. Maybe you would like to spread it a little bit. Now, as far as backup destinations are concerned, we see that customers tend to have many different backup destinations. So it can obviously work as a standalone solution. So you can just grab your existing storage, put it, use the duplication that we already have here, maybe attach it over some iSCSI or fiber channel, whatever. Or you can connect to some of the backup providers that we already support. So there is a huge there are huge options available in here, especially that some of the storage already on the market are S3 compatible, for instance. So if you think about object storage or S3 in general, it's not always just Amazon. It can also be integrated with some existing storage that you have in place. Now, for Kubernetes, this option is not available, but it's worth to mention that we have option to mount backups for specific environments. So in the single pane of glass, you are eventually able to see multiple hypervisors, like I see right now, coming from, well, we'd say multiple virtual environments, and you're able to protect them with a single console. So you don't have to deploy multiple instances of them. Obviously, if you would like to scale, it's not always about the scaling per se, because vProtect, even single vProtect node can handle significant amount of workload. Sometimes it is just better to spread work across multiple nodes to have more, have less impact on your infrastructure. So it is your infrastructure that basically can be affected. Now, two main questions. Well, what is the level actually on which you are protecting your containers? So we have discussed here currently persistent volumes. Well, with these persistent volumes, you are also protecting metadata. So whenever I have, let's say, Nginx deployment, this is the one that I have recently backed up. I would like to restore it, for instance. I would like to restore it directly to the environment. Now, this is the option for you to customize. Sometimes you would like this persistent volume to be specifically changed. Maybe you would like to have your persistent volume created on your own, or you would like, for instance, to just automatically generate for you. Project here is basically namespace. So I will put test here and I will execute restore task in the meantime. So we are talking about persistent volumes at this point. We have seen customers also that run Kubernetes on virtual environment. So they quite often use snapshot-based backup on the VM level, which holds basically Kubernetes itself. So several VMs on top of which you have Kubernetes running, and persistent volumes, technically, they don't matter in this case because you are protecting your complete Kubernetes environment using regular snapshot-based virtualization, basically protection level. So it can be VMware, it can be OpenStack, it can be regular standalone KVM server. It really depends on what type of technology you're deploying. Finally, it is quite often, there is an assumption that if you have Kubernetes, you don't need data protection at all because all you need is etcd database. So now there is mechanism built in here. It is generic mechanism. It allows you to protect individual applications in a very custom way. So if you have some applications running on your Kubernetes, maybe you don't want to focus on the container itself. Maybe you would like to back up your Postgres database, some DB2 database, whatever, something that is running inside the container. And maybe it is very custom. Maybe it's just this application generates some set of files, they need to be protected. And you don't want to use the Kubernetes way of with some small downtime and copying persistent volumes out. This allows you to basically create a command configuration. Some of the templates are already provided for you, and this allows you to cover everything else, which is not provided by default. This means etcd protection, because basically protecting etcd is just a single command that allows you to dump something. So you can present it to vProtect just create me a dump of your etcd database, and I will store it later in the S3, in the IBM Spectrum Protect, in Catalogic vStore, whatever you have actually in mind. Now, this is something that allows you also to use your existing scripts. If you want to protect, for instance, Postgres database, maybe you don't want to use snapshot itself, because protecting databases using snapshots on the VM level can be sometimes crash consistent. So it is something that you may want or may not want to do. It really depends on your disaster recovery strategy. However, this allows you to execute this custom command either from the node or from via SSH, over SSH. So this expects you that either this script or command or whatever you like to execute is there, available, or installed some client, maybe like MySQL database client on the node itself. And you are able to create a template. Let's say I would like to create a template for my to protect my database. And I know that this script, let's say, expects DB name. All of these parameters later are going to be passed as the environmental variables to your script. So like DB name. Okay, it's not that user-friendly, but it's basically something that it's okay. And it's called, let's say, MyDB. It can be shown. You can also say how we should handle errors. Okay, so if your script executes with some non-standard zero codes or with some warnings written on the standard error, etc. So it is very flexible, and it allows you to protect individual applications depending on how you would like to approach your containers. Sometimes you don't have SSH, okay? So that is why you would like to execute local command that connects just to Postgres database using regular client. Now, you create this command configuration, and later, once you have such configuration, you're able to define your instances and assign policies as usual. So here I have our internal database basically protected in the same way. So I have some sort of, I have particular command execution config assigned to this particular instance of my application. So you can imagine Kubernetes etcd database. You can imagine your database running inside the container. So it is, so as you can see, we have 3 layers of protection here. So it is either persistent volume layer, it can be an application layer, or it can be infrastructure, let's say, layer. So either using the virtual machine layer on which actually Kubernetes resides, or if it's just etcd protection, it's also one of the aspects that you would like to consider. Okay, I believe that we have covered everything for now. So maybe let's jump to the Q&A.